Hi, we're going to cover different alternate views that don't fit into our standard 6 orthographic projections, like your front, top, right, left, bottom, those, etc., or your standard isometric, like this right here, right now. This would be a front view, and this would be our front, right, and top ISO. So we're going to go through and look at some other alternate views that you might use in helping communicate information about your parts. The first family of views we're going to talk about are section views. A section view is where you slice the part, you remove a chunk of it, and then you look back to see what you removed, and you can see material that's been cut. And the profile that's left behind helps you understand how that part was created. A section view is defined by a cutting plane. This shows where the cut was made. The arrows show the direction that you're looking from. So in this case, we cut with a horizontal plane coming basically from where we're looking, kind of straight through. In this bottom part, so this is the front view, we sliced right through it, all the way through, and what's behind the arrows is the section that gets removed. The arrows show that we're looking now up from the underside. The section view is going to show that perspective. And down below is the section view. In the section view, you have these diagonal lines. Those are called your hatch lines, and they show the material that was actually sliced. So what part of this part would have made contact with a saw blade? So this is the profile left behind after making a cut. We remove the entire bottom half, and then looking up from underneath, our entire view is a section view. Notice, in all of this view, we have section material along the top of it, on the left side, on the right side, along the bottom, the left side, the right side. So this is called a full section view. Okay? Just to compare that with a half section view. A half section view, which this is your view, this is your section view. Half of the view, the top half, is not showing any diagonal hatch lines to show that material's been cut. But underneath this line, the bottom half does. So we have half of the view shows a section view and half of it does not. To understand how this one was made, we can come over here to what would probably be like our left view or maybe a top view depending on how they define this ISO. But this would not be the front view of our part. This is a view where we can see just a bunch of concentric circles, and maybe it's harder to understand the part. But it's a good view to create a half section view. So if I only want to show half of it because the object has symmetry and the section view is going to be the same, just a mirror image of each other, perhaps I want to show part of it not sectioned and the other part sectioned. So to do that, we've cut out only a quarter of the part. Okay, so the arrow down here shows that I'm looking from the right to the left. My section line shows that I've cut out this wedge. This is the cutting plane. If I cut that material and remove it, and I'm looking right to left this way, then when my eyes hit this part of the part, there's nothing been cut and I'm going to see the outside. But when I'm looking down here below this cutting plane with this removed, then right along here, I will be seeing where the material's been sliced, where the knife has touched the part, and I will be seeing these section lines. I'll see that profile. So I had to remove a quarter of the part to get a half section view. Another type is an offset. Sometimes your cutting plane, to make one straight cut wouldn't go right through the center of the features. Often we want to go through the center of a feature to help show the inside and understand what that feature is. And so here we have some holes and some material that's been removed from the part, but they're not all three in line with each other. And so here a cutting plane has been defined such that it kind of zigzags through the center of these features. In the end, we get what looks like a full section view because kind of my full view is really showing sectioned or material that's been cut away. But these lines right here show that my cutting plane took a turn. And so we call this an offset section view. Okay, so those are all in the family of being a section view. Cut material away, we look back towards the part where we removed a chunk and we can see material that's been cut away, kind of that surface that's left behind after making the cut. Okay, another type of view is an auxiliary view. An auxiliary view is a view that lets us see what would be an angled plane, an angled surface, at an orthographic projection that we wouldn't otherwise have gotten within our 6 standard orthographic views. This part has the trapezoid defined as the front view. With that defined as the front view, the right view would actually be, just change colors here, okay, would be this plane right here. That's what would be perpendicular to my line of sight. This is the right view right here. So the bottom here is material that's closer to me than the top. The top is further away in the right view. And I can dimension here, but this dimension, that 0.48, is it's just not, let me turn my drawing tools back on. It's not a dimension that's on the surface, and perhaps we want to see a dimension that's actually along the surface. So this 0.48 is actually this dimension here, which is just kind of out in space on a vertical plane. And then looking down from the top, this 0.27, actually I didn't get from center hole to that edge. That 0.27 would be from here to here. But if we had dimensions, so the difference between 1.09 and then all of that, just to get this dimension, would be this purple leg. It's really a right triangle. But what if somebody actually wants to know on the plane, on the angled surface itself, where's the center of that hole, and what's that dimension on the surface? We might want to look at this surface orthographically. So an auxiliary view is a view that does just that. It allows us to select this surface and then turn it so that it's facing us. And so you can see that the hole still, it looks circular, where in these other views, notice that the shape looks different. They look like ovals or ellipses. That's because we're not looking at them orthographically. So an auxiliary view is going to turn this angled surface towards us so that we get a true orthographic projection. Then when we dimension the that side or features on that surface, we have dimensions that are actually on the surface. Okay, that's an auxiliary view. The last view is a detail view. And also in here, I'm showing a long break. First, a long break is just basically cutting the part. It's a long, continuous part with no features that are unique. It's a repeating pattern. And so if I cut a section out and I still give you the information about how long it is, you'll still understand the part. So a break line is just cutting a section out, and we use these lines to kind of define that, hey, we've removed material. So that's showing in this picture as well. But the alternate view here is the detail view. And that is where we take a section of our view and we actually want to zoom in on it. So this right here, this circle with the arrows with the A, is defining that I'm going to show you this area zoomed in and kind of removed and pulled away. And that's just called a detail view. So a detail view is zooming in on a part, blowing it up, and putting it somewhere else. The reason why we do that is that in the context of this bigger picture, it might be really hard to get little dimension lines in here and have them easy to read to show how big these teeth are, what the angles are to define it. And so if I can cut that out as an example and then blow it up over here, I have more space for my dimension lines to show angles and lengths. Okay, those are all of our alternate views that we have covered. Section views, cutting with having a cutting plane and cutting the material and looking back to see that cut material to get a profile. Auxiliary views that take an angled surface and turn them orthographically towards us so that we can dimension on the surface. And detail views. Detail views zoom in on a section of the part and blow them up and give us more space to really show and understand the detail involved.